Hey everyone, today I am here to introduce to you the HOPPR Marie Curie Chest Radiography Foundation model, show off some performance metrics, and demonstrate how ML developers can fine-tune it via our API. Alright, if you want to get in contact with us to gain access to fine-tune these models, please do hit up the Contact Us form on our website. And then before we get into it, sorry for some background noise. I'm out here in sunny Southern California, and some background about me. My name is Evin. I have been an ML engineer here at HOPPR for a couple months now. But on to our performance, right? So here is a radar plot showing the ROC AUC values for a couple different models, one of which is HOPPR's. Other two are Microsoft's MedImage Insight and Google's very recent MedGemma. All right, so this area under the receiver operating characteristic curve metric, right? Basically, what it means is when you have any part of that model's line that is further out towards the edge of the circle, that is better performance, to put it simply. And we can see here, it is not across the board, but these are some preliminary results that are all about, that are all on fine-tuning jobs of each of these models that are comparable setups. And we do see, in many cases, these initial preliminary results, we do show the HOPPR Marie Curie Foundation model performing quite well, even outperforming, right? One example here being bronchial wall thickening is just a random one I chose, but it shows a relatively large discrepancy between the MedGemma Google model on the green line being furthest in, the light blue line being Microsoft's model being a bit in the center, and then the HOPPR purple line being furthest out towards the edge, meaning highest performance, right? So just to brag about all of that, we can now get into the actual HOPPR SDK, which is the Python way to get into our actual API. You can install it with a pip install over at PyPy. And very, very high level here, how it works is once you have filled out the Contact Us form on our website, you will get access to API keys, which you can then use bringing your own data. Right now, it is a bring your own data setup. In the future, HOPPR will provide our own internal data for you to subset and intelligently sift through in a way that finds you the best subset for your own use case. But anyways, once you have your API keys, you go ahead and get hooked up, and then you can upload your actual data set with your DICOM images. We do, of course, have expectations in terms of label formatting and all of that, which you can read all about over in our documentation. And then when it comes to actually fine-tuning your model, starting the actual training run, we give you access to a bunch of hyperparameters and whatnot. And then we do have asynchronous API calls, meaning that you separately create a training job and separately get a response to actually check its status, right? And when you do check its status, you get a bunch of info, such as what stage it's in. Here, for example, we are de-identifying the data currently in this little example snippet. And then finally, once it has been done training, the actual fine-tuning process is finished up, you can go ahead and run inference on your new model by uploading individual images into a study, and then finally running that study through the actual model for inference and getting out your response, which in this simple hello world style application is just a very easy binary classification predicted probability, right? Is all we've got going on here. But that is about it for today. Thank you all for watching. Again, if you want to get in contact with us to get some API keys and get up and running on your own as a developer, you can hit up that Contact Us form on our website. We will get you started. And I do also have to read off this disclaimer. The HOPPR Foundation model is not a medical device. The regulatory pathway depends on the device manufacturer's intended use and final software application. Device manufacturers should make any necessary modifications, validate model performance in the final product, and obtain any applicable regulatory marketing authorizations before commercialization. HOPPR provides tools and component-level documentation to support regulatory preparation and alignment. And yeah, thank you all for watching. End of video.